Hello students, good evening to all of you. Today we will study the problem number 2 on molecular formula and empirical formula. Let's see the statement of the problem first, students. An organic compound on analysis gave the following percentage composition. Carbon equal to 57.8%, hydrogen equal to 3.6%, and rest is oxygen. The vapor density of the compound was found to be 83. Find out the molecular formula of the compound. Students, again I am going to explain this problem. Actually, for solving such kind of problem, you need to learn one table. So I am going to solve according to this table only. See, this is the table. This table consists of the 6 columns. First, second, third, fourth, 5, 6 columns are there. In first column, you have to write the elements. So how many elements are there? Carbon, hydrogen, and rest is oxygen. Means that there are 3 elements are there. One is the carbon, second is hydrogen, and third is oxygen. Okay. Now, in second column, we will write the percentage of carbon, hydrogen, and oxygen. Here, percentage of carbon is given 57.8 and percentage of hydrogen is given 3.6, but percentage of oxygen is not given, but it is given in the question. The rest is oxygen, means that out of, because total if you are going to add, it should be 100%, so it will be subtracted. 100 minus 57.8 plus, okay, 3.6. If you are going to subtract this data, you will get 38.6%. Okay, now we got the percentage of all the element, carbon, hydrogen, and oxygen. Now we will write the atomic mass in the third column. Atomic mass of carbon 12, atomic mass of hydrogen 1, atomic mass of oxygen equal to 16. Now in fourth column we will find out the moles of atom. So here, what is the formula of moles of atom? Mass of atom upon atomic mass of the element. So here the element carbon is there, its percentage is 57.8. So 57.8 will serve as the mass of carbon. So we will write mass of carbon, that is 57.8, divided by atomic mass of carbon, that is. After division, you will find here, that is the 4.8. Here mass of the hydrogen 3.6, atomic mass 1, you will get 3.6. okay. Now for oxygen, mass is 38.6 and atomic mass is 16, you will get 2.4. So here we got the number of moles of carbon is 4.8 and hydrogen 3.6 and oxygen 2.4. So for finding the, up to this is very easy, but for finding the mole ratio, what you have to do? You have to please focus over this line. For finding the mole ratio, try to find out, there are, you find out all the moles. So already you find out 4.8, 3.6 and 2.4. Out of these moles of atoms, find out which is the smaller one. So here if you are going to see in this value, 2.4 is a smaller one. So by the smaller mole, you have to divide the other moles for finding the moles of mole ratio. So here for 4.8 will be divided, here the smaller value is 2.4. So we will divide all the mole of atoms by 2.4. So for finding mole ratio, so 4.8 will be divided by 2.4, you will get 4. 3.6 divided by 2.4, so here that is 3 by 2, that is 1.5. okay. Next 2.4 divided by 2.4, you have to divide all, so you will get 1. So here we got the moles ratio equal to 4, 1.5. Here not 4, it will be not 4, it will be equal to 2 only. Okay students, 2 times, okay, it will go 2 times, 1 and 2. okay. So here we get the 2 value, 2, 1.5 and 1. So but these values, these mole ratio are not whole number. So here you can see 1.5 is there. So we will make this 1.5 as the whole number. Whole number value we have to write in the last column. So here for making 1.5 as a whole number, we will multiply 1.5 by 2. So we get 3. So for making 1.5, I multiplied it in 1.5 by 2. Okay. So we will multiply by the same number by 2 in other mole ratio. Why we will multiply by the same number? Because to making the composition same. If you are not going to multiply by same number, then composition will be changed. So we will multiply by 2 also by 2. So it will come 4, and in 1 into 2 it will also come 2. So now here up to this we got the number of carbon atoms, that is C4, number of hydrogen atom 3, and simplest whole ratio of the oxygen equal to 2. So simplest whole number ratio for the carbon 4, for hydrogen 3, for oxygen 2. Now we will find out empirical formula. Empirical formula. Okay. Empirical formula equal to, here how many carbon are simplest whole number ratio? Carbon 4. So we'll write C4, C4, H3, S3, and O2. So this will be act as the empirical formula. This is the empirical formula of this compound. Now we will find out what is the empirical formula mass. Empirical formula mass. So empirical formula mass, here 4 carbons are there, plus 3 hydrogen are there, and plus 2 oxygens are there. Okay. So here 4 carbon, atomic mass of 1 is 12. 3 hydrogen, atomic mass of 1. 2 oxygen, atomic mass of 1, 16. So here 48 plus 3 plus 32. You will get here by adding 2, 3, 5, 5, 8, 3, 4, 3, 7, and 1, 8. So 83 gram. Here we got the empirical formula mass equal to 83 gram. Okay. Up to this is very easy. Now we have to find out the molecular formula. Our aim is to find out the molecular formula only. So molecular formula equal to N into empirical formula. Okay, but we don't know what is the value of N. So first we will try to find out the N equal to molecular mass upon empirical formula mass as we know that molecular mass equal to 2 into vapor density. So here 2 vapor density is given in the question. You can see, students, vapor density of the compound was found to be 83. So its value is given 83. So here we will write 83. So we get the molecular mass equal to 166 gram. So we will put the value, students, here. We will get 166. Empirical formula mass already we calculated 83. So we will divide by 83. We get N equal to 2. Okay, we got here N equal to 2. Now students, what we have to do, we'll put the value of N here in this formula for calculation of the empirical formula. Okay, so here molecular formula equal to N we got N equal to 2. So we'll write 2. Empirical formula equal to C4S3 and O2. Already we calculated here C4S3O2. So we will multiply C8H3, C8, 2 4 ja 8, 2 3 ja 6, C8H6O4. So students, this is the molecular formula. Okay, formula. So this is the answer. So hope students you got the concept. Thank you. Have a good day. Okay, thank you.